All right. Stay over there. So let's call son's age X, and you call my age no way. Okay. Y. So 7 years ago, my son was 1/3 my age at that time. So 7 years ago, how old's my son? 7 years ago, how old is my son? If my son is currently X years old, 7 years ago, he was X minus 7. And I am how old? Y minus 7. Okay. And they tell me 7 years ago, my son was 1/3 my age at that time. So my son is 1/3 my age. Yes?
Yeah, that makes sense. That's
Okay.
right.
So my son was 1/3 my age. So that's one thing they tell me. And then they tell me, so here's one thing they tell me. And then they tell me 7 years from now, is that what it is?
Yeah.
He will be half my age. So 7 years from now, how old am I? Let me put it in the same order. How old is my son? 7 years from now. Here we are now. 7 years from now, how old will my son be? X plus 7, and I will be Y plus 7. And they tell me that he is 1/2 my age. My son will be 1/2 my age. Okay. Crazy. Now, do you have to use algebra to do this? No. As I was writing this out, there's a way to consider this differently. But this is one way you can kind of set it up using variables, right? Yeah. If you can explain why what you did works, I'll accept it. Because yeah, sometimes you can just take numbers, try to do something, you get the number and the answer, and you're like, there you go. But if you don't understand why it should work, then it's no good. Yeah, thank you. I haven't made a pile yet.
Okay.
Now that one, real quick, that one, it didn't say a certain way to do this, so you could actually guess and check, right? It didn't say use a variable. It just gave you a problem, so you can actually use any of the methods that we have. You can draw them if you think that'll help. Yes?
On 6.3 set A, number 12, there was a problem that it said we have to draw a picture.
Sketch each representation. Oh, using the chapter 6. Oh, I see. All right. Yeah, so don't. All right, so 6.3a wanted you to use their expensive online stuff, number 12. So don't worry about number 12.
Okay.
It's referencing something you don't have access to. I didn't make you get it because it just costs too much money. Yes?
6.3 set A, number
21?
28.
28. Okay, let's see. So in December, about 481 out of 999. So a fractional part of the oil. Let's see. So they tell me. Let's see. December of 2012, right before everything collapsed because the Mayan apocalypse. 481. this fractional part of the oil refined in the US was produced in the US. Refined in the US was produced in the US. Okay, so that fractional piece. And then they tell us that if the United States produced 7 million I think it's this number. Is that right? Yeah. Barrels per day. Blah, 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 blah. There it is. How much was being refined at the time? Okay. Blah, 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 blah. Okay, I'll make sure I do that all right. So this fraction of the oil refined in the U.S. was produced in the U.S., right? They tell us how much the U.S. produced, and then they ask us how much is refined. So one way to do this, I gave you an example earlier this semester. One of my favorite ways to try to start a problem is to come up with a simpler problem, right? So if I said 2/3 of the oil produced in the refined in the U.S. is actually produced in the U.S. Right? And then I said 30 barrels produced in the U.S. All right, let's see if we can figure out this easier problem. Right? It's got smaller numbers to deal with. So 2/3 of the oil that is refined in the U.S. was produced in the U.S. So real quick, do we refine oil in the U.S. that's from somewhere else then?
Iran?
I didn't ask where, I just asked yes or no.
Yes.
Yes, obviously. In this example, 1/3 of the oil we refine comes from somewhere else, correct? You guys with me? If 2/3 of the oil we refine was produced here, 1/3 must have been produced somewhere else, right? So if we produce 30 barrels in the U.S., how much do we refine here?
45.
How'd you figure that out?
I divided 30 by 2 and it's 15, so 15 would be 1/3.
Yeah, because
I don't know if that makes sense.
if I knew, so this one's a backwards kind of question. So if they asked us instead, let me ask a different question right here. If they ask us, if they tell us, produce, okay, 20 barrels refined in the U.S. Let's say 21, bam, refined in the U.S. How much is produced in the U.S.? I think the situation is just so wordy, it gets lost, and the math gets kind of lost in the wordiness, but 2/3 of the oil that we refine in the U.S. is produced in the U.S. If we refine 21 barrels, how much did we produce? I would just do 2/3 of this. I would just multiply those, right? And then what you realized is they're not asking me, they're not telling me how much they refined, they're telling me how much we produced. So then I have to divide instead of multiply. So I have to take, so over here, when I had 30 produced, you divided by 2/3. I love it. Instead of multiplying by 2/3. Because it's the opposite question. I don't know if that helps out at all. Okay. The rest of you guys okay? Have you guys hit that problem yet?
I've hit that problem, and
Okay.
I did the problems on set A, but I'm on 6.3B.
Real quick. This method, when you have kind of disgusting looking numbers to deal with, We have a very gross looking fraction, poor little fraction, but you're gross looking, I'm sorry. And you have a rather large number, correct? You could sort of on the side create an exact same problem, but with a nicer fraction and a nicer number. Because then your brain might latch on to this better, and then you just do the exact same math with this. A lot of students feel like that's cheating. It's not a damn thing wrong with that at all. Instead of drawing a picture, I just made a simpler problem so I can see what to do. Yes?
I'm on 6.3, set B, 15A.
Okay.
It says use the method described in set A, exercise 15, to find the following quotients. And I'm looking at that, been looking at that yesterday, and it's like, for example, let's just say, for example, it says 4/7 divided by 2/7 equals, and then it said so 2 times 5.
No. All right.
I mean 2/5 blank.
All right. So 15.
Yeah, 15A.
They reference you back to number 15, and they say use the same method in 15A. So.
And the problem was like 3/4
All right.
divided by 6/9.
And the method used in 15A so we got a blank here. There you go. Oh, and then they continue. So they say, okay, here's the setup. We're trying to figure out what this is. And whatever the answer is here, that must mean this is true. That's what division's all about. 6 divided by 2 is 3 because 3 times 2 is 6. Okay, so that's really all that's saying. But they go on to say, okay, here's what the method they use. So they look at this. And they say, okay, 4/7 divided by 2/5. And in here they put, where'd he go? Oh, I skipped a point. I could do it. 2/5 times. There we go. In this box, they put, see if this makes sense. 5/2 times 4/7. Okay, now why is that going to work? If I want to make, so basically what I want to have happen is I want to multiply 2/5 by something that'll make 4/7 left. Does that make sense, what I just said?
Makes sense.
Stay with me now, this is kind of cool. I want to multiply 2/5 by something that will make 4/7 be left, correct? Okay. If I multiply 2/5 by its reciprocal, what do I have so far? 1. And if I want 4/7 to be left, I just have to multiply by 4/7 then. So then what do I multiply 2/5 by to get 4/7? Well, what's this? What's this?
That 5, 10, 15, 20. 20/14. 2
2 goes into 4
Oh, 2 goes
twice.
Twice, so
it'll be
that'd be 10 over 7.
So, okay. Maybe.
That makes sense, because I was referring back to the algebraic version. Perhaps maybe because I was I didn't know what to do with the bottom number. Like, for example, I was working on 3/4 divided by 6/9.
What was the original problem again?
It was in 15A, 6.3, set B, number 15.
Yeah, all right. So you've got your 3/4 divided by
6/9.
6/9. So
Yeah.
you just follow the exact same setup that they used, right?
All right.
And then whatever you get in this box is the answer. This is what is this approach here? You can do it. When I'm trying to divide, I can set up a multiplication problem, and what is missing? It's the missing factor approach. So like, remember subtraction, we can use a missing add-in approach. So when we say 7 minus 3 is what, we can go, well, what plus 3 is 7? That's the missing add-in approach. So you're building subtraction off of addition, which they already kind of understand, which is the general theme of math, is build, 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 right? So all this is the missing factor approach, which is how you kind of do division based on multiplication. But then they have a really kind of nifty little dude where they kind of take advantage of the reciprocal to sort of directly work it out instead of, and of course, why does this kind of make sense? The reciprocal comes into play because how do I do 4/7 divided by 2/5 officially now? How would we do it? What's 4/7 divided by 2/5?
4/7 times 5/2.
Yeah, and look what ended up in here. 4/7 times 5/2. It's kind of like another proof that division by a fraction is multiplication by the reciprocal, which is kind of nifty, to be honest. Maybe? So you follow that exact same steps that they have in number 15 in the first part, in part A. Is that better?
That's better.
Okay. Let me see, who else? Emma. Yes. I scanned it. I got to send it to her, but she can have her original too. By the way, let me say this now that everybody, or more people are here. What's happening Thursday?
No school.
No school. It's crazy. Something I kind of left my brain, but it's on my little homework sheet, so it kind of kept me straight too. I was like, oh yeah. So we have a really strange in the middle of the week holiday. I still have my Friday class, which is fantastic. Can't escape. But Thursday's off. So when is our next test?
The 18th.
So a week from this Thursday. Right, yes, a week from this Thursday. So what do I have for you today? I've got the practice test. Holy shit.
Well, wait, I have one last question.
Yes.
Number 11, 6.3.
11 part
6.3.
6.3b?
Yeah.
Okay. Draw squares similar to those in set A, exercise 11. Okay. To illustrate the following division problems. Okay. So did you understand 11 in set A? Is that the problem?
Well, we tried to draw out the pictures, but did we have to cut each squares into pieces? Or
Yes.
Okay.
So here's the idea. This is kind of a nifty idea. If I want to do 3 divided by a half, well, here's 3, right? And remember, division is all about 6 divided by 3 is 2, because if I break 6 things up into 3 groups, there are 2 in each group, correct? So 6 divided by 3 is 2, yes? So I can kind of do the same thing. If I break up these 3 into groups of a half, how many groups of a half are there? 6, yeah. Which is another illustration of it must be 3 times 2. That's how you get 6. So it's sure enough, it's dividing by a fraction is multiplied by the reciprocal. Is that cool? So, what if I had to do this? 4 divided by 1/3, what would I do? I got 4 boxes. And then I cut up each of them in thirds. Chef. Yeah, you're doing fine, Jeff. Keep going. I can, on and off, I can count. So, 12. Okay, so you can see visually the answer is 12. It takes 12 1/3 pieces to make 4 whole boxes. I love it. Yes? So this is really important for you and for students to understand. The idea of division cannot change just because you're doing fractions now. The idea of division is the idea of division, end of story, right? So that's why the way we did this, 6 divided by 3 is 2, has to still work, even though we're dividing by a fraction. Now, Is it easy to visually capture this?
No.
No, so we try to get away from that. We try to develop simpler processes to attack something directly. But when you're introducing a topic, you want to make that connection. The idea division doesn't change just because we have new kind of numbers to look at, like fractions. You guys all right? Yes.
I'm still on 6.3, just learning about it. I know we should be on chapter 7, probably. But yeah, I'm nowhere near on chapter 7 because I'm still learning 6.3.
Oh, are you just telling me? Did you have a question?
I just worried about the quiz, because, yeah, I mean the next exam, the test, which is on next Thursday.
Yes, next Thursday, yeah. So I've got the practice test. What I'm considering, so there's a couple things. We're obviously a little behind the new schedule. So we still have chapter 8, chapter 9, correct? The amount we've got, because it also includes section 5.2, if I remember correctly. So I've got the practice test. The actual test is not going to be as long as the practice test. So the practice test is kind of long. I'm going to have to kind of pare it down. But I am concerned about the amount of homework. To be really honest, you should be able to do it. We've got a week and a few days until our test. So you should be able to catch up. But if you're in chapter 6 and about to get in chapter 7, there are 4 sections of homework, right, in chapter 7. So what I'm considering doing, let me just go ahead and make it official. I got a feeling this is not going to be enough for some of you guys, but section 7.4 homework won't be due on next Thursday. Yeah? But it will still show up on the test. And that's assuming we make it through that today. We'll find out. All right. So Thursday being a holiday, sort of gives you more time, but holidays are few and far between until we get to Thanksgiving week. So I understand wanting to take advantage of it in a different way than just doing math. Yeah.
For 15A, I got 3/2. Is that right? 15A for sub B.
Oh, well, I mean, you should be able to just do the problem directly,
Yeah,
right?
but I don't think
To know what the answer's
I
gonna
was
be.
I was doing it right because what I did was okay. So 3/4 divided by 6/9. I did equals 6/9 times, and I did 9/6 times 3/4.
Oh, you did it backwards. Okay, so two things. You're doing it the way that I would do it if I was done with the actual question they asked. That you're checking your answer. Or you can do it ahead of time just to know what the answer is going to be. You're doing it the algorithmic way that we've developed. They asked you to use their specific method from the earlier number 15. So you still have to do it that way. The mistake you made was, help me out, guys. Which one flips?
The second?
Yes, and you sort of turned it around, didn't you? You put the second one first, didn't you?
Yeah, I did the 6/9 times 9/6 times 3/4.
Oh, okay. So, all right. So you did turn around, but it sounds like you flipped the correct one. I just don't know why. Yeah. So 3/4 divided by 6/9 is 3/4 times 9/6. And of course, 9/6 is actually 3/2, right? But
3/2, like, would that be?
so you're not going to get 3/2 as an answer, right?
No, it's not.
Okay. So you
So
can do
the-
this just to see what your answer should be, but you're not answering the question yet.
Yeah, because this is what I did, because yours is a little different than mine.
But this is how you do it.
Yeah, but I put in 6 over 9. This is what I did, or 58.
Oh, I see. So you are, okay, now I understand. Okay. And then you do this and that's your answer. So I don't know why you said 3 halves, because that's not what this is gonna be.
Yeah, this is what I was like doing, because I didn't multiply, but I did, but another
Oh.
3 and 6 can go
No.
into
9 times 3.
18.
No,
Oh, no,
9 times 3.
oh, 9 times 3.
Okay. Okay, now it makes more sense. Let's see, anything else from homework stuff? Are you guys, gonna turn, do you have any homework to turn in, maybe?
Oh, I have a homework that you gave me a
It would
correct.
help if you give me homework, yes.
Yeah, I have homework that you gave me a correct on. I was gonna turn it in today, but I left it at home.
You're fine,
Can I turn it in on the email?
It's not due until,
Yeah, but can I turn it in on email? I took a picture of it.
if you want to, that's
Oh,
fine,
okay,
yeah.
thank you.
If I get it in some way or another, I can print it out and do it, yeah.
Thank you.
Okay, all right, guys. So let's get into where we are. We finished 7.1 and 7.2. All about decimals and stuff. Today we're going to talk about kind of 2 things that are intimately related. So the last 2 sections of chapter 7 kind of go together really well. 7.3 is ratio and proportion. And we should all be pretty, I would think, we should be pretty decent with this, but let's find out. So let me ask you this. Let's say I've got a bunch of M&Ms, right? I got some, anyway, it's, anybody else in the camp with me about Christmas? It's a little too early for Christmas stuff. Or is anybody in the camp where it's too late, Christmas should be there already? No. All right, it's too early for Christmas stuff. Okay, good. And the rest of you guys are like, I don't want to speak up because I don't feel bad. I'm not going to think anyway of you. But let's say I've got Christmas themed M&Ms. So they're all red and green, correct? And the ratio of red M&Ms to green, is 5:2. All right, so have you guys seen ratios written like that before? Especially if you've gone betting on the horses, right? Anybody ever? I don't. Huh? You do? So you see the odds written like that sometimes, right? Okay. If there are 140 total M&Ms, how many are red, how many green? So you know they're in the ratio 5:2. What does that mean to be in the ratio 5:2? For every what, there's what?
For every 5 red, there's 2 green.
For every 5 red, there's 2 green. Is that cool? That's what that ratio means. So right now, this is an example of a part-to-part ratio. Have I explicitly written like a total number up there, right? No. What's the simplest way for this to be true is if I had how many M&Ms total? 7, and 2 of them are green and 5 of them are red, yes?
Yeah.
So what if I had 14 total M&Ms? How many would be red? Is everybody with us? Is everybody with that? Is that cool? And if you're not, you can just tell me. It's okay. Because we don't use ratios a lot. We're used to using fractions where the bottom is the total. Ratios are sort of like fractions taken apart. I don't see a total in them. Now, if you wanted to, you could express these as fractions. What would this... Are you going to work for me, Green? Sort of. Poor little dude. What fractional part of the total M&Ms would be red? 5 out of 7. 5 7s are red. And then, of course, 2 7s. I want to say are blue and then keep the thing going, but it's too bad. 2 7s are green. So make a little color. And then I could do, like I said, if there are 14, I could do 5 7s of that to see how many red and so forth, but it's much easier than that. If there's 7, there's 5 and 2. If there's 10, if there's 14, then there's double both of these. So I have 140 total M&Ms. Right? Are you guys with me? So 5 to 2, I really want this to make sense. If I got a 5 to 2 ratio, it's all built on there being 7. If there were 7 M&Ms, 5 red, 2 green, no worries. If there are 14 M&Ms, what's the multiplier? 2. Right? Instead of 7, there's 14. Now there's twice as anything. Twice the 5 is 10 red. Twice the 2 is 4 green. 10 and 4 makes 14. Yay! So this is basically how ratios kind of work to build them up. So if I have 140 total M&Ms, what's the multiplier? The multiplier of 2 will get me up to 14, and then I need another multiple of 10 to get up to 140. So 20. Okay, so I don't know if you guys are with me or not. So 5 to 2, 7 total, right? 10 to 4, 14 total, right? Yes? I like it. This poor little dude probably doesn't like it too much. You like it? No? Sorry, little dude. There you go. Don't you fall over. Okay. And I could keep going, couldn't I? And of course, this I multiply by 2 and so I multiply this by 2. 2 twice must mean twice the total. Then I got to multiply by 10, don't I? To get 140. They told me there was 140. So I just do this times 10. So that'll be 100 to 40. There's the 140. So I got how many red? 100. How many green? 40. Okay, I like it. I like it. So one way you could see a ratio is part to part. And another way you can see a ratio, and this would be related to a fraction, would be part to whole. Okay. So this is one kind of problem you could see with ratios. There's many, and let me just show you this way. So there's one way to do it. It's kind of like the multiplier effect, right? Another way to do it is to say 5 to 2 means 5 7s, because 7 total are red, 2 7s are green. So if I have 140 total, 140 total, how many are red? 5 7s of those are red. 7 goes into 140 20 times 5, 100. Same problem, same answer we got. Same thing for the red, for the green. I like it. As always, multiple ways to get to the same answer. Okay.
Why is it 5 over 7 when it's 5 over 2?
No, it's not 5 over 2. It's 5 to 2, a ratio of 5 to 2. Now listen.
Ratio?
Yes. Meaning for every 5 red, there are 2 green. What's the smallest whole number of M&Ms you could have to represent that ratio? 5 red, for every 5 red, there's 2 green.
7?
No CG. So if there's 7 M&Ms, yeah, if there's 7.
Because you added the 5 and 2?
Yeah. So that's kind of like if I made it into an actual fraction, because what's the bottom of a fraction most of the time represented? Represents the total. Yes? Something out of something. So 5 out of 7, right? A ratio does not have to represent a total directly. So I could make it 5 out of 7 red, 2 out of 7 green, and then this whole multiplier thing, 5 out of 7, if I multiply top and bottom by 2, it's 10 out of 14. 2 out of 7 times 2, 4 out of 14. There's the 10, there's the 4. Yes?
Uh-huh.
Okay, I like it. All right.
So 10. So Okay, so 10 and 4, okay.
Okay.
10 and 4. But then you got 100?
Because I knew I had 140 total, right?
Uh-huh.
If I said I had 14 total, I would have stopped right here, because isn't that 14 total?
Uh-huh.
But I was supposed to have 140 total, so I had to keep going.
140 total, so you added them. Oh, so you just added the 0.
So 5 to 2 is 7 total, yes?
Yeah, so you added a 0.
10 to 4 is 14 total.
Yeah, so you added it by
Yeah,
two,
so I had to multiply 10 to get to 140 total. Kick ass.
And that's it.
Yeah, and then we can just read it off the parts of the ratio to see what they are. So
Mm.
once I multiplied by 2 and then by 10, that part is 100 now, that's red. That part's 40, that's green.
140, and that's it?
Yes.
Because it's right over there, it says 5/7, and then there's 20, and then you get.
Yes, because another way, a whole other way to do this problem is to use fractions instead.
Oh.
This means 5 out of 7 would be red. So if I write it as a fraction, I lose the direct sight of 2. I really want you guys with me. If I write it as a ratio, I don't directly see the total, do I?
No.
But I can see it's 7. I can add them together. If I write 5 out of 7, it doesn't directly tell me how many are green, but I can work out there's 2 out of 7 green, yes? So there's just 2 different ways to represent the same situation. Okay.
God, and what chapter is this from?
7-3.
7-3.
What am I doing with you? All right, here we go. So when you get into ratios, you will have discussed things with fractions, which is another reason why you want to bring back in, this is what it would look like with fractions, because they're a little more comfortable with fractions at that moment. Okay. Blah, 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 blah. So what's kind of funny, the earlier problem we were doing, I think during office hours, there was a problem that we had to do sort of cross multiplication, but we sort of know cross multiplication already because we talked about this. When is that true? What must be true for that to actually be true?
You have to times A and D and C and B, and yet in order to be true, if they're equal to each other.
Yes, I like it. Okay, so that we know. We already know this. So we've already sort of done the base work for proportions. Can somebody tell me what a proportion is? What is a proportion?
I've heard that word before, but I can't remember the definition.
Say again?
Part of something?
So watch this. Let's do a classic proportion problem. Classic proportion problem. On a map. What you got, Jeff? Let's say 1 inch. No, let's make it more interesting. 3 inches is 50 miles. So you look at a map, you got a scale, yes? Even if you look at Google Maps and you zoom in, your little scale changes, yes? I'm talking about back in the day when we had these crazy ass things. And you're like, where are we? Sitting on the side of the road. So on a map, 3 inches is 50 miles. If you are, what you got, Jeff? 180 miles from your destination. How far apart is that on the map? How far is that on the map? So you can set up something to answer this question. Yes?
180 divided by 50.
Not quite. Because you never took this into account, right? So here's one way to do this.
Over 50 equals
Yeah.
something over 180.
3 on the map, 3 inches on the map to 50 miles in reality is 180 miles in reality, and I don't know how many, so 3 inches on a map is 50 miles, So 180 miles is, I don't know how many inches. So all a proportion is an equality of two ratios. Yes? And we know this. We know this. If 3 inches is 50 miles, 6 inches is how many miles? 100. Holy shit. So that division has to stay constant. The proportion has to stay the same. Right?
So we multiply 3 times 180.
Yeah, cool. Right? This is a classic place where you use cross multiplication to solve it, right?
And then,
Using this more basic idea of the only way a fraction can be equal to another fraction is if this is true. Now that's going to help us figure out what x is. Yeah. So you get 180 times 3.
and then you get 50x.
I like it.
However, 540 divided by 50, you would get 10.8. So it would be
Sure.
a fraction.
It's got to be a fraction, right?
Mhm.
Because 180. So what you're doing, 180 divided by 50 is to see how many groups of 50 miles, and then you still have to multiply by 3 after that. Okay, I like it. 10.8 what?
10.8 miles or inches.
There, yeah. Just go back up to where you defined what your variable is. Okay. Does this feel familiar? You guys remember this kind of thing?
I kind of remember now when
And there's problems like recipes, remember? Takes 1/3 of a cup of flour to make this, and you want to make 28 million of them. You know, so how many cups of flour do you need, right?
Flour.
Yes, flour, okay.
What about money wise?
Okay, sure.
Do you know any problems based on money wise? Because I remember going to see just 7 point something, and they were talking about money. Like
We'll see if we hit any.
okay.
All right. How about this? This is sort of money because it's gas, which we all know is basically money. So if you get a car averaging 29 miles per gallon, right? How many gallons are you going to use? Are used on a, what do you got, Jeff? Oh, sure, why not? 609-mile trip. Now, some of you guys are going to understand that, and I appreciate that earlier attempt without using a proportion. You don't necessarily have to use a proportion, but it's kind of a nice thing just to capture the whole idea. There's sort of a hidden proportion here, right? What proportion is that? Yeah, 29 miles, and the per, of course, sets up the ratio per gallon, equals so I know that every 29 miles takes a gallon, and how far do I have to go? Yeah, 609. And I don't know how many gallons they need. I like it. Okay, so this should feel, hopefully, semi-familiar to us, doing this kind of thing. And you just cross-multiply and solve it like normal. Yes, maybe? Okay. I'm not sure why I picked these numbers. I have no idea. Let's see. Whatever that comes out to be. I just always imagine somebody putting them in big barrels in the back of their truck saying, I'm not going to pay those prices across the border. It's great. So they're just taking all this gas with them. I don't know how many gallons are they going to put in their truck. Too many, and I'm not going to drive anywhere near those people.
It's going from Arizona and to California that far, like per se San Diego to Scottsdale, Arizona.
Okay. I actually have no idea. If that's 609 miles away. What is that, by the way? Has anybody done that? What is 609?
21.
21?
Yeah.
Holy shit, it goes in even?
Mhm.
Look at past Jeff go. All right, I was trying to figure out why I picked those numbers. So 21 gallons of gasoline. I like it. All right, sweet. Give or take. Okay, so not too bad. Good old ratio stuff is not that terrible. Okay. I don't think they throw anything too weird at you. The ratio and proportion section's pretty quick, and there isn't anything too strange. Okay. So all the strangeness is reserved for the percentage section. So and this is where I'm going to finally shut up for a little bit. I got a little handout for you guys to work on. So if you're really getting tired of listening to me, I'll shut up here in a bit. I'm going to erase this here. You ready?
Oh, sorry.
I'm always disappointed if there's not at least one person that says, "Way." Okay. So can somebody tell me, what do you guys know about percentages? Tell me anything you know about percentages.
They're annoying.
Are we still on 7.3?
7.4 now. 7.3 was just ratios and proportions.
Oh,
It
now,
was very direct, very straightforward.
so 7.4 is now percentages?
So Luis claims they're annoying. That's given them some ability that if they have it, it's really scary to me. If they have the ability to annoy, what else can they do? Then you're like, you don't want to have your math books in it too near your bed because I don't know what they're going to do. They're feeling really upset. Anything else about percentages? What does percent mean? Just percent. What does that word mean? You guys know? How many cents are in $1?
100.
100. Holy shit. So percent means per 100, right? So literally, 7% means 7 per 100. Holy shit. So a percentage wraps right into the whole idea of ratio, proportion. So if 7% of my oranges were stolen, that means 7 were stolen for every 100 that I had. Is that cool? That's all that means. Okay. So what about, so now we got the basics of percentage. So how would you write this here then? 128%. How would you write that as a fraction?
128/100.
Holy shit. So anytime you see the percent symbol, it's an automatic over 100, right? And then you can reduce it or make it a mixed number or anything else I'm not interested in right now, right? This sort of leads into the next thing, of course, because now we got to tie it into, if I could tie it to fractions, I have to be able to tie it to decimals. So right here, what decimal would this be?
1.28.
1.28. And what decimal would this be?
0.07.
Yeah. So again, you guys all should know this. If I want to go from decimal to percent, if you write these in alphabetical order, it tells you the direction to move the decimal place. If you write D for decimal and P for percent in alphabetical order, this is just in case you have trouble remembering. If I have a decimal, I move it this way to make it a percent. Another way to more analytically look at this, the percent symbol means divide by 100, correct? That's what the percent symbol means. It means out of 100. So if I see 7%, has it been divided by 100 yet? No. So the percentage number will always be bigger than the decimal number because the decimal is what I get after I've divided. Maybe? Okay. All right. So what about, let's see, how about 0.2%? What would that be as a decimal? Yes, 0.002. Part of me loves that some people seem to feel like, oh, the poor little dude is so tiny. I don't want to make him tinier, but it's just what happens. when you go from percent to decimal, the number is going to get smaller because you are dividing by that 100. You don't just have a simple saying, don't forget to divide by 100. You're actually dividing by 100, so it just gets smaller. Kick ass. All right, what about, what do you got, Jeff? 14.9. Change that to a percent. You guys don't trust me.
1.49%.
1,000.
Two things wrong with that. You have to move twice, right? Why? This decimal to percent, I don't care which way you're moving or whatever, it's always twice. The whole, why? Because it's all based on 100, which is 2/10.
Do you move twice to the right or to the left?
So that's why I did this here. I'm going from decimal to percent, so I'm going to move that way.
So
Once, twice. So our brain balks at that for several reasons, right? Is anybody concerned about that being bigger than 100? Why does that not matter worth shit? You can say CEO's pay has gone up by 1,490% since 1987. That's probably pretty close to true. It's actually probably small. So yeah, what's a 100% increase? What does that mean the price did? If the price goes up by 100%, it is double. Couldn't price triple?
Yes.
So you can have more than 100%. So really, when you're talking about something increasing or decreasing, if you're talking about a part of a whole, you can't have more than 100%, correct? Jimmy ate 120% of the pizza. It's like, what? He created pizza and ate that too? That's some shit. Pizza, yum. Right? No, okay. All right. Now I want that superpower. All right. Okay. So that's the basics of those. What if I bring into play, of course, fractions? Let's see. Yeah, we can do this. Yeah. Sorry, I came up with what this could be as a phrase, and I can't say it out loud.
fraction,
There you go. Okay.
that
So
fraction,
if I had the fraction 4/5, can somebody come up with a nice quick way without dividing to make that into a decimal?
2.5, 0.25, like, or no, wait, 75 cents. I'm sorry,
This is all very neat. So, all right, so you're thinking 1/4, I think, that's where 25% comes. 75 cents, I'm not sure where that came from. But decimals are easy from fractions when the fraction has a bottom based on 10. Yes? So anytime the bottom is not 10, but it can become 10 real easy, that's the best way.
It's 0.8, isn't
8
it?
tenths, 0.8, exactly. So 0.75 is a pretty good estimate. Now, then I can do a percent. That should be relatively easy.
80%.
Good. Once, twice, 80%. Kick ass. I like it. And of course, if they gave you something like, what do you got, Jeff? 3/17? What would you do? Can you make 17 into 100 easily?
No.
No, not easily. You could do it, but not easily. So what does that mean, of course? What does this mean? What does this tell you to do? What does it tell you to do?
Give up.
What operation is that?
Division.
Somebody French? What?
Nope.
Okay. Division. So somebody help me out.
Oh.
What is 3 divided by 17? Give me a few places.
By 5, because 3 and 5.
Wait. No. 17 is not a number I can work with easily. So there's no kind of way to manipulate this like this, not really. We're just gonna go ahead and do what this says to do. It says to divide, correct? That's the whole point of it.
Yeah, like I thought I was doing like 3 and then 7, like the 3 outside the divisor. Or
Okay, sure, but it would be 17 into 3.
Oh.
But go ahead and use your calculator, it's fine.
Okay, so
Yeah.
well, I would get point.
Give me a few places for this.
0.176.
176?
Yeah.
Yeah?
Point
And then,
one.
of course, as a percentage, what would that be? Bam, bam. 17.6%. I like it. Kick ass. Now, next stage, and then I'll give you this worksheet. There are several different ways to approach percentage problems, especially when you're trying to teach them to young people who don't really know too much yet. One way to do it is, remember that grid that had like 100 pieces to it? I'm not going to draw them all, right? Blah, 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 blah. Yes? And it represented a decimal, right? So it represented 1 in each of these. How much would each of these be? This is 10 by 10. How much would each of these be?
1.
No. 100ths, right? If you cut it up into 100 pieces, each piece is 100th of the whole thing, yes? You guys remember that? It was that blue thing with the yellow things up on the top. You guys completely forgot. Okay. All right. So, if I wanted to do, what do you got, Jeff? If I wanted to do 10% of 5,000. If I said this whole grid represented 5,000. Yes, and there's 10, 10, 10, 10, 10. If this whole thing represents 5,000, what does each little box represent then? No, come on. If the whole thing, again, how many parts is the whole thing broken up into? 10 by 10. So how many parts is it broken up into? 100. So if the whole thing is 5,000, each little piece would be, if you break 5,000 into 100 parts, is that, because that's what we're doing, correct? If the whole grid is 5,000, whole grid represents 5,000. What is 100th of that? 50. %, stay with me now. At the same time, one block is 1%. Is that cool? Yes? Did we figure that out just a minute ago? Isn't? All right, I'm not sure what's happening. So if I take one grid and I break it up into 10 rows and 10 columns, one piece is 100th of it. Okay. I can look at it as a percentage. So one piece would be 1% of the whole thing, 1 out of 100, right? I can also look at it as the whole thing represents 5,000. Because if I'm asking what is 10% of 5,000, well, 100% would be 5,000. That's the whole amount. And now I want to cut it. So if 1% is one piece, and one piece is 50, well, how many pieces would make 10%? How many pieces would I need to make 10%? 10. And if each piece is $50 or 50, 10 would be 500. So you can do it with a grid. You can have the grid. The grid is kind of nice because, again, it breaks down to 1%, 2%, 3%. Every little block is 100th, which is automatically 1%. So if you want to do some percentage of something, you say the grid is 100%, so that's 1%. And then you say the grid is also completely, the whole thing is 5,000. So then one piece would be 50. So 10% would be 10 pieces, 500. Okay. Maybe.
That actually makes sense.
Some kind of sense? Okay.
Some kind of sense, yeah.
And I have to tell you, before the semester, I had never seen those grids before, right? So, I mean, this is kind of as new to me as it is to you. But you can imagine, you go to a school that actually has those things that they connect, not the little crappy things I was trying to create and pretend like it was the right thing. But you can actually like lock them in there. So students will love playing around those shit. So they already will be familiar with this from decimals, Now you can make the connection between decimals and percentages, and that helps them kind of build on that for the next thing. Yes?
Are we gonna have to make grids on homework?
I
Or
don't think
see
so.
grids?
No.
Okay.
I mean, at worst, you have to draw something like I've done.
Ugh.
Yeah. Which, if you do at least that good, then you're fine. Then you've got, let's see if you guys know this one already. Have you guys, so what if I said, so this kind of problem is a very basic example of a problem like this. 7 is 10% of what? Does that bring back any memories to anybody? Did anybody learn a method to solve that kind of problem?
7, 9, 10.
Anybody learn any method? Anybody learn a method sort of sounds like is over of?
Yeah.
Okay. Well, how does that method go? Do you remember?
No, this is.
You're like, dude, I remember is over of. That's it. Okay. So one method is, and this method is a method I personally don't like as much, but it's just too bad for me. I make a proportion. So this is the proportion method, right? 7% means for every 100, there's 7. Yes, that's what 7% means. So that is a ratio in its own right. 7 is the part out of 100 total. What's the total up here? 7 is this part of total. So the what is the total. The of piece is the total. So part out of whole. Maybe? No? 7 is 10% of, okay. So what is the total up here? What's the total amount? 7 is only 10% of this. We'll call it X. Is that better? So what is the total? What's the total amount? I'm not asking you for a number. So the answer could be X, for example. Because that is the answer. Okay, I love it. So if I said, anybody in here left-handed? Nobody? Anybody in here have blue eyes? Anybody in here have a pet? Okay, okay. Keep your hands up. All right. 1, 2, 3, 4, 5, 6, 7. And then there's 11 total of us, right? So if I said, so what percentage is that? Somebody help me out. 7 divided by 11. I know it's 63.6, right? Okay.
It's gonna be 63%.
So if I said 7 is 63% of the total number of people in here, right? Of 11. Isn't 11 the total, of course? Okay. 7 is 10% of something. So isn't this the total? Isn't this the total amount? And 7 is a part of it? Okay. So is over of, I always hated that because it's really simple. Depending on the way they kind of put the question together, you can mix up is and of. So it's part divided by a whole. Are you guys worried about that? I am too. Sorry. So there's an X there. Right. So I don't know, there's not an X there. We'll get it eventually. All right. So is over of equals X over 100. There we go. There it is. So is over of is P over 100. Percent over 100. Okay. So the P is just the number that's in front of the percentage. So where should the 7 go? Where should the 7 go? Is 7 the total or is 7 the part? Yeah, the 7 is the part. So 7 out of I don't know, right? Is over of. 7 is 7. Of what? I don't know. And that's got to be 10%. Okay. So I don't know why I was so fixated on 7 being the percent at first, but 10% means for every 100 things, 10 of them. Okay. So that's why you start looking at me crazy. Right there, you can just say, Jeff, you having a moment? I say, oh shit, I am. Okay. So 10%, that's 10 for every 100. That sets up the overall ratio, and I want to know 7 would mean there's a total of what? Okay. Personally, I don't like this method too much. But here, what could you do? Cross multiply, yeah. So 10x equals 700, right? Do bam, 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 and then divide by 10, and you get x is 70. Okay, it makes sense, right? 10% is 70, sure enough, is 7. Man, my 7 and my 10 want to be the same number. I love it. The way I would do this problem. So this is the proportion approach. You got the grid approach. You've got the proportion approach, which I know a lot of you guys kind of reacted when I said is over of, because you kind of remember that phrase. And then you've got, we'll do the same thing, a much more direct route to do this. This is basically somebody reading an equation. What is the word is, do you think, in an equation? What would it represent in an equation? If I said 7 is x, how would you write that equation? Equals. I love it. So is equals. 7 is 10%. What is 10% as an actual number, as a decimal? 0.1. And what does of mean, operation-wise? Do you guys remember?
Divide.
Oh, hell
I love you. What is half of 80? What's half of 80? 40. Didn't you do 1/2 times 80? Yes. What's up? Okay. Yes, maybe. The word of used to be understood by everybody. That it was multiplication. And then high school said, oh, we don't have to teach them all that shit. And then you get to college, you get to take my class, and I'm like, holy shit, nobody knows what of means anymore. But of is multiply. So if I had a box, one box has 7 parts in it, and I have 3 of them. How many parts do I have? One box has 7 in it, and I have 3 of those boxes. How many parts do I have? 21. 3 times 7. Of means multiply. So 7 is 10% written as a normal number of, I don't know. So wherever you see the what is where you put your variable. Now how do I solve that? Yeah, divide by 0.1. And I can do this by multiplying both top and bottom by 10, yeah. And so I get 70, which is exactly what we got that way. Okay. So this is the equation approach, which is a very creative way to identify it. I write an equation for it. What's up? So another example. If I said, what is 14% of 90? What would that look like as an equation? What are you saying?
What?
Why?
What?
Yeah, what? Good. All right. What do I put down there for that? I don't know what it is, right? What? I don't know what the hell it is. So I put a x. There we go. There you go. Is becomes equals. So what becomes x? Is becomes equals. 14% becomes 0.14. Of means times. Okay. What's up there? Are you okay? Yeah. What's going on? What? Have you, who's ever seen this approach, this equation approach? And okay, if you've never seen it before, I already know some answers to this, but does it make sense?
Yes.
If I ask you, read me this equation, wouldn't you say
What?
something is 0.14 times 90? Wouldn't you say that?
Yeah.
Yes? If I said, read this equation to me, you'd say something, I don't know, is 0.14 times 9. That's basically one step away from what this says. This is somebody reading an equation in English. We just have to write the equation they're reading. That's all it is. This is a pseudo equation. One step away from an equation. Okay. So the beautiful thing is, no matter what part of it you don't know, the equation will set up the same way. So if I had 11 is what percent of 121, how would you write that equation? 11 equals x times 121, yeah. Oh. And it's really beautiful because if you have to do algebra, you would want it to look like this, would you not? You would want it to be a one-step equation, sometimes maybe even no-step equation, right? Here you just got to do this. Here, what's the one step?
Right.
Yeah.
I'm trying to see the other problem. Thanks.
Whatever that is, I don't know. Is it 090909?
Yeah.
Yeah. 9.09%. Is that cool? Bam, bam? Okay. All right. So. Let me give you this. So what I want you to do, don't talk to anybody first. I want you to try it on your own for a while, and then I'll let you check it out with other people.
I've been writing notes.